Hello, my name is Buddy Marcy. Welcome to my code review video. The purpose of this video is to introduce artifacts from my capstone project for CS 499 at Southern New Hampshire University. I'm going to outline the enhancements to the artifacts that I intend to make, describe how those align with the course outcomes through these three topics: software engineering and design, algorithms and data structure, and databases. My first artifact is the dashboard. Sorry. The first artifact is the CS340 final project. This is a dashboard that links to a database in Python. The database that we used for this course was built on Oporto, and a lot of the function of it was abstracted. It was provided and it ran only in the virtual environment. So the parts of the artifact that I have are this Python middleware and this Python dashboard that uses the middleware to access a database. The database itself was a 10,000 line animal shelter database, hence the animal shelter calls here. This will align with the software engineering and design category, and also the databases category, since this does directly interact with a database. See, I have a slide that shows a picture of what this looked like. I can't actually run this because I'm not in the Oporto instance. I don't have access to that anymore. But this is what it would look like when the dashboard file was run. We have these radio buttons here, a logo, and we would pull a bunch of information from the database and show it in a table along with a graph and a map. This code here is the Python middleware that interacts with the database. So we have our initialization, and then we have create, read, update, and delete functions. Standard things that you would see for database interaction. The dashboard file here imports the dash library, as well as NumPy, Pandas, Matplotlib to put our visual elements into the dashboard. We would call our database here, and then we would build the dashboard that you could see in the previous picture. A lot of the values in this are hard-coded values, things such as the radio buttons would use a pre-built query to the database to pull its information. So when you see these radio buttons here, if I were to click water rescue, you can see from the code that if water rescue would go, and it would automatically do this full query to the database and pull the information and import it into the dashboard. Pretty simple project overall. This was all on a local machine, like I mentioned. We were using Oporto. We would host the Mongo database was in Oporto, and then all of these things all ran in the same environment. I think that system was actually, I don't know that it was actually running on the virtual machine that we were signed into. I think it was actually on a different machine. Let's say all of the things like this, our actual connections to it were statically assigned and abstracted away. This was provided to us. This instance of MongoDB was already running when we began our project. So let's look at some code review. I went through the checklist, going through each of the different topics to check for in the code review. I started with the middleware. I'm not going to go over every single thing in here. Some of it isn't relevant, or some of it is passing. So what I would like to talk about are the instances from the checklist that are deficient in the code. The first thing we find is leftover stubs in the comments. This is line 38. I have some things here. I had a print statement in at one time, and I commented it out. I was actually asked by a professor to do this after the one of the iterations of this project. But I left all of this in here. This really needs to be cleaned up. Uh, there are constants in the code instead of calls. That's these things here. This constructor should actually be built in a way that you could input this information instead of just hard coding in values for these. The same in the dashboard file. We hard code in the username and password and then pass those into our constructor, and we really shouldn't do that. We should have some implementation where a user could put a username and password and perhaps abstract away these, but we also want to be able to pull different databases and not just one static database. For documentation, the comments need to be cleaned up. There's just an awful lot here, and a lot of it doesn't need to be here. Things like create method to implement the R in CRUD. Well, it's pretty obvious what the read function does because it's called read. So these are unnecessary and need to go away. Also, I put my own timestamp things in here, but that would be better fit in a header file or a header comment instead of all over the place like they are in here. We did this in various iterations, so it made sense at the time. They need to be cleaned up for the current project. For loops and branch, there are no arithmetic operations in this in the code in either of these. For loops and branches, the only time I don't have any loops here at all. The only if-else statements involve error checking, that raise exceptions if there's no data passed, this sort of thing. So these are all just for error checking. There's no other logic stacked here. For defensive programming, there's no timeout. There should definitely be let's say when this was all on a single machine, you don't worry about it too much, but once we get into our enhancements, there should definitely be a timeout set for calling this data from somewhere, or a connection check. We'll probably do all of that in one kind of in one function together, but it does need to check and see if there's a database to actually pull and a connection to Mongo in the first place. Moving on to the dashboard, let's say that this doesn't do anything on its own without a Mongo database, so this would have to be changed in order to talk to an actual MongoDB instance somewhere. There are some stubs that are commented out. There are no lines in this is a Jupyter notebook file, so there's no line numbers, but there are a couple of things like this debug statement that's here. There are a few other stubs that are here and there that have been commented out but that are still in place. So things like some of the instructions are still in here. These don't need to be in here. Like I mentioned before, the username and password is hard coded into the file. We would rather have dashboard entries to enter username and password and not statically assign them like this. The documentation for section here, are the comments consistent with the code? They're not very consistent here. There are a lot of comments, as you can see, but some of them are instructions. Some of them are very wordy to explain what they do. This, in particular, this one says Mongo versions will return an ID column, and we don't use the ID column anywhere, and it'll actually get in our way, so we need to drop that column. But there's 4 lines to explain what this one line does, and that's not necessarily a bad thing, but there's just too much. This could be summarized quite a bit. Same thing with a lot of the codes in here, and then there are large sections where there's nothing. So like this doesn't really say anything. So a lot of this is going to be changed up a bit in my enhancement anyway, but it does need more consistent commenting. The variables in this are all good. There's no weird ones. There are some instances where we'll say things like we'll call something data or we'll call something DF, but these are pretty standard abbreviations for the libraries that we imported. The loops are good. The only things that really loop, I don't know that anything actually loops here. We actually just do a compound query, and other than this being like a statically assigned hard-coded thing, which this is okay too if you want to define this button this way, but it really kind of narrows down the functionality of what we're doing here in our dashboard if you only have like preset options. We want to make this much more usable. Again, like we mentioned in the first section, there's no timeout set. There's no connection check when we load our info here. We make this call to load our data from the database. We call this function and initialize with the hard-coded values, and we just assume that it works. There's nothing here to say it worked or didn't work. There's no error. There's no timeout. There's nothing here to if this doesn't import a database, then it just doesn't. So that definitely needs to be addressed. So while we're looking at this project, before I get into the other artifact, we'll go ahead and talk about the enhancements that I intend to make this, and we'll talk about the course outcome alignment, how this aligns with the expected course outcomes. So the first thing I want to do, because this doesn't work without having a Mongo instance, I would like to have a database in the cloud. So I'm going to spin up an EC2 service on AWS and put a web server and my a MongoDB database in the cloud in a way that you can actually connect to it in some kind of a way. We'll serve that out with an API, and then we'll cause this. We'll make this initialization stuff actually reach out to that API instead of just like a hard-coded local instance. That's the first part. We'll obviously be removing some hard-coded items from this. We'll probably make just a dashboard entry for inputs, along with our whenever we build a dashboard, we can actually set up a splash screen, a beginning screen to authenticate. We want to be able to authenticate a user and a password with my database server. We need to build a proper constructor. That's part of getting rid of these hard-coded functions. Implement sign-in authentication. That's just part of having a database. Here we sign in with just a basic username and password, but we would do the same in the cloud. We just need to authenticate that connection. We need to implement timeouts, like I mentioned before, and connection checks to make sure we actually have a connection to the other end. Make sure we, when we connect to the API and try to pull a database, that we can actually do that. And then we're going to rework the dashboard a bit. Instead of having just a bunch of static buttons that call statically assigned queries, we want to break this down a bit so that you can actually use it. This doesn't do very much on its own. Like it is, you really only have a couple of options to search through. You can't really search by anything. The Plotly lets you, I think it's Plotly. I'm actually not sure which. Maybe just a dashboard function. But anyway, the sorting functions are kind of built into this, and that's kind of nice, but you can't really search for anything here. This is, as a dashboard, it's not especially useful, and it shouldn't require too much refactoring to make it so that you can actually search for something in particular, or sort this list better, or show more results within a function of the page, that sort of thing. Just a better dashboard. The course outcomes for this, put on slide 4. Employ strategies for building collaborative environments and enable diverse audiences to support organizational decision making in the field of computer science. By making a good dashboard that allows maybe a non-technical or less technical end user to access a database in a way that's more palatable. So a database engineer can just go to the database. They don't need a dashboard like this. They already know how to get in and write a query and that sort of thing. But your regular user who could actually use this data probably doesn't know how to do database queries, wouldn't know how to connect to it in the first place. And then we use Python middleware and Python code, but making this into a nice, neat dashboard where anyone can use it is kind of the definition of building a collaborative environment. So this should designing this program should meet this course outcome requirement. Here, demonstrated an ability to use well-founded and innovative techniques, skills, and tools in computing practices for the purpose of implementing computer solutions that deliver value and accomplish industry-specific goals. This really seems mostly like a branch off of this. This is an ability to, I'm going to use well-founded libraries, and we're going to pull data for end users in a way that, I've already kind of described how this delivers value, and that your regular end user can't probably pull values from a database or put things into a database or do any of the database stuff. But having a nice, neat, easy dashboard, like anybody could use this, to find, in this case, it's to find different types of dogs, but you don't have to know how Python works or how Mongo works. So this would definitely deliver value to any organization. And Outcome 5, develop a security mindset that anticipates adversarial exploits in software architecture and designs to expose potential vulnerabilities, mitigate design flaws, and ensure privacy and enhance security of data and resources. This will be demonstrated in the deficiencies listed in the code, setting timeouts, doing connection checks, building authentication to the server, so that only authorized people are allowed to use to access the data that we have stored there. And that is artifact 1. So now we'll move on to the second artifact. My second artifact is our CS300 data structures and algorithms. The purpose of this was to load a CSV file that was provided for us into a program and have a data structure to hold it, and then make various queries to the data that we put in. So this one actually does run. This runs in the command line. So you can see here we have the option. We have to load bids first. So we'll do that here. We'll load the bids. Get a little timer. It tells us how long it takes. We can display all bids, this is like I said, a pre-built file that we were given. We have a find bid function that finds a bid and times how long it takes. We have a remove bid. So we can remove, it actually removes this one, and then if we try to find it again, it goes away. It says 0, not found. And then we have an exit. So that's what this does. So the header file here and the parser were provided to us. The code in these is sound. Going through them in from a code review perspective, the only thing that's missing here is that it's obviously completely devoid of comments. There's nothing describing what any of this does at all. The variables used throughout are usually standards, things that I see, POS for position, IT for iterator, this kind of thing, but not particularly descriptive, although what this does is kind of straightforward. It seems like a lot of code, but it's really just it's just parsing a CSV file for the data that's in it and putting it in a way that we can actually organize and use it. So the binary search tree part of this is the part that we wrote, and some of this was also provided, but we kind of built on it over the course. So we have definition for a struct. So we build a bid, and then we build a node. And we were given the choice between making a hash table, a binary search tree, or a vector to store our data, and I chose binary search tree for my project. So here's my binary search tree implementation. Here's all of my private and public methods required to instantiate a binary search tree and perform the necessary functions like adding a node. In order, pre-order, and post-order are just traversals. They're run recursively so that we can pull the data from the binary search tree in different ways. We have an insert, a remove, and then a search function. So all of these my constructors are all built here, and then my recursive, say search is here, add a node, and then my recursive traversals are all listed here, and then we have a display. We have load bids. This is actually what happens when you hit that one button in the main function. So this is what actually loads in the CSV file, and in this case, it's in the folder along with the working program here. So we run the parser on it and pull the data and build it all into bid objects that we can actually put into the binary search tree. We have a string to double function because in our initial our actual struct is 3 strings and a double, so we need to be able to cast that into a double. And then we have our main function. So this one again is hard coded, like a lot of the rest of the work here. The main gets called with the default, and we hard code in values for the default. This is the CSV file that we were given that we load in. And this is a statically assigned bid key. So when we call our remove, we remove the bid key, and when we search for the bid key in the default cases without doing anything. This is mostly just to prove that it works. It's not useful as a function. So okay, yeah, that's what this does. This gives us the menu and then leaves. So for code review, again, just like before, I went through all of the items in the checklist for the code review, but I'm not going to go through each thing here and talk about all the ones that are good because it's unnecessary. So again, in the header file and the parser file, other than some weirdly named variables that could be a little bit better, the only thing is there are no comments here. For the main file, ordered code calls. So we made these in order, post order, pre-order traversals, and we only use one of them in our main function here. When we say option 2, display all bids, when we have the switch case of 2, we use the in order traversal to print all of the values, but we never actually use the post order or pre-order traversals. We built them as part of the BST, but we never actually implemented them in the course. So I actually did make a 5th and 6th switch case, but these were unnecessary to match the details of the finished product in this course. So I wrote them in here as different cases that could be called, but they're not actually items in the menu. I think actually if you go in here and you load the bids, I think because of the way I have this built, even though it's not listed as an option, you can actually do the other traversals, and you can see that one's in a different order. So they're there, they just don't do anything, they're just not listed here. That's are there any left over? Hold on. Yeah, unneeded procedures or unreachable code or uncalled for. If you're not going to use them, there's no reason for them to be there. So there should be some reason to have them there. Well, like I mentioned before, the main switch cases have hard-coded values instead of variables. So again, you can't enter a bid to search for because we hard-coded in, this bid here. This would be much better if you could use some input validation and enter a value instead of it just taking the hard coded thing. Same thing with the remove case. We talked about commented. This was a little bit earlier in my computer science journey, and I have a lot of comments in this code that are things like this: loop to read rows of a CSV file. That's obviously what this does, so there's no reason to put a comment like that. Same thing. There are a lot of very small comments that are very obvious, like if match is found. I don't need to explain how this works. It's pretty obvious through the code and what it's trying to do, how it works. I could put like a summary at the beginning. But there's no need to have a line at every one of these. I didn't know better at the time. For the variables, everything is okay here. We have the only thing that was weird is the casting, but we do actually cast a double when it's appropriate. We have the function just to cast string to double. So for the arithmetic operations, again, there's no arithmetic in this. It doesn't actually perform any kind of calculations. It just builds a binary search tree and makes it searchable. So it doesn't count anything or perform any arithmetic. The only thing that's labeled funny are these in order, pre-order, and post-order calls turn into in order, post order, and pre order with capital letters. And this seems like a really terrible way to do this because these are very confusing. Am I calling the post order with a lowercase, or am I calling the post order with the uppercase? And these are initialization values so that you can actually pass the root to the function, and then it recursively calls them, like when you go to in order down here. That uses what you passed in from the root node to recursively work from there. But these need to be different. They need to be more different than just a capital letter. For loops, the only thing that I have as an issue with loops is that there is no depth protection. When we're recursively calling several things here, we're recursively calling in order, post order, pre order. And on recursive calls, we do need like a depth check so that we don't get so crazy that we crash the whole computer. I'm not sure what that value needs to be, but there should be something so that you don't have a stack overflow. So that is the code review for this program here. So while we're here, I'm going to talk about my planned enhancements for this. The first thing I want to do is convert this from C++ to Python. That demonstrates a pretty valuable skill these days. There are still quite a bit of C++ code out there in the world, but there are a lot of being able to update that to something that works with more modern tools is a valuable skill. If nothing else, if I were to convert this to Python, right now it reads a CSV file and builds a binary search tree out of the data. But if I were to convert this to Python, I could actually make it work with my other dashboard program to work with a database instead of just a CSV file. It could do more things, or we could write to a database. And you could probably do that from C++ also, but I don't know why you would do that now. It would just be better to work this in Python. One thing I would need to do is build in the documentation for the parser file and the parser header. Let's say there's no comments at all in this, but since I'm rewriting this into Python, it'll give me ample opportunity to add those. One failing of a binary search tree is the data that you feed into the tree needs to be sufficiently randomized. My awesome professor for this course gave us a CSV that is sufficiently randomized in case we wanted to build a binary search tree. If you were to populate this binary search tree with a sorted list, though, a sorted CSV file, you would end up with a root node, and then all of the branches would go down to the right. So it wouldn't be a binary search tree so much as a very terrible linked list, and it wouldn't be particularly efficient at, its entire purpose is to be a more efficient way to search for data. So what I would like to do instead of the standard binary search tree, there are a couple of ways to solve this, I guess. You could try to write a function that would sufficiently randomize any list that you brought in, but any of those are going to be, you never really know how much you're going to get, how much randomization you're going to get. And then you have to decide what you want to do. Do you want to randomize it 10 times? Is that sufficient? Is it 20 times? Could you still end up with a really unbalanced and unwieldy tree? Of course. So what would be better is if we were to implement a self-balancing tree. I think I'm going to go with a red-black tree in place of the binary search tree. So a red-black tree has a bit of logic applied to it. Nodes, on top of having their values that they would have, whatever object, and then a left pointer and a right pointer, they also have a color. They'll either be red or black, and then logic gets called based on what color the nodes are, and when you do an insert, it'll determine where it needs to go in the tree, and then it'll check the colors of things, and if the colors don't line up the way that they need to implement this logic, then rotations happen, and the rotations balance the tree, so that at the end of it you'll always have the root node in the middle and an even number of branches all the way through. The logic checks it whenever you add something or remove something as you go along. We'll still use some of the things like in order, pre-order, post-order traversals to display the data, although they should be either all the same forward or all the same backward because it's a balanced tree. But a red-black tree makes more sense. Then we don't care if the CSV file that we import is sorted or if it's not. So another improvement we want to make is we want to improve the dashboard. Like I said, right now there's a handful of static values and some things that it doesn't even call. So we would like to clean this up a bit, and so when we have things like find a bid, then we go down here and we implement the find a bid. Instead of statically assigning a value to this, we want to be able to input a value so that we can find it within that. We'll have to implement input validation for these items just to make sure we don't get any kind of weird, so that you have to put in something that matches. So maybe you print a list and then you can see how they go, and then you can search for a specific thing. But this implementation overall, this doesn't really do anything. There are a couple of hard-coded values and it loads the file that you've parsed, but other than that, it doesn't do anything. Maybe there's some maybe enhancements that I would like to do if I have the time permitting. I may just translate this into Python and let it work with the same CSV file that we were already provided with, or maybe a different one, but I might have two versions of it, one that's sorted and one that's not, just to show performance difference in the red-black tree. But if I have time and a future implementation, whether I get it in for this project or not, would be to make a better parser so that this works specifically with the file that we were given. It has to be that number of rows and that sort of thing. It's very specifically written for that file. This could be done so that it works with more varied CSV files. This will still pull the information from a CSV file, but ignore empty columns if there are fewer columns or that sort of thing. And the other maybe would be, instead of trying to fix this CLI menu, we might maybe try to build a dashboard like we have in this project here, where we can actually sort, we could perform the functions that are in the CLI, but from an actual dashboard instead. I don't think that implementation would be too much, but I'm not sure that it's strictly necessary, and it's definitely going to take some time. So those are my enhancements for the second artifact, the artifact 2. These are the course outcome alignment values here. Some of them overlap. We had 1, 4, and 5 here. We're going to have 1 and 4 also here. The third course outcome, design and evaluate computing solutions that solve a given problem using algorithmic principles and computer science practices and standards appropriate to its solution while managing the trade-offs involved in design choices. This is going to, this whole program takes data from some basically unsorted source and compiles it in a way that's efficient to sort. If you were trying to just go through a CSV file and find a value, it would be very difficult to find what you were looking for. So this is supposed to make that much easier. A binary search tree can perform searches in big O of log n time. So once you've loaded the data into your database or into your data structure, you can perform functions on it very quickly. So that's the entire purpose of loading this into a data structure. You kind of do the data requirement on the front end, and then after that you have a very efficient method of storing your data. Just like before, employ strategies for building collaborative environments that enable diverse audiences to support organizational decision making in the field of computer science. A user of this program doesn't need to know what a binary search tree or a red-black tree is. They just need to know that it's making their job faster and easier. A less technical person can find what they need to find by using this tool. That also falls into this, demonstrate an ability to use well-founded and innovative techniques, skills, and tools and computing practices for the purpose of implementing computer solutions that deliver value and accomplish industry-specific goals. Much like the dashboard file before, if you had the CSV file of data, you could just read through the 10,000 lines and find the thing that you're looking for. You could put it into Excel and maybe find some way to sort that way or that sort of thing. But by giving these tools and using some computer science, we can make this a lot more efficient. And that's the whole purpose of this. So you'll notice between these, I have 1, 3, and 4. 1, 4, and 5, but the second one is missing. So the second course outcome is design, develop, and deliver professional, quality, oral, written, and visual communications that are coherent, technically sound, and appropriately adapted to specific audiences and contexts. So this is going to be demonstrated through the journal entries. We have journals in 4 of the milestones, in 4 of the modules of this course. We have already turned in a planning documentation sheet, and then there are presentations such as this one. So the course outcome number 2 will be handled through this video and many of the weekly assignments that we turn in through the course. And that should cover all 5 of the course outcomes. And we cover the 3 different areas: software engineering and design, algorithms and data structures, and databases. By designing the dashboard app to work with a cloud-based database, putting the database in the cloud satisfies the database requirement. And then it's a pretty standard way to deal with data and dashboards these days is to have a cloud-based data and web server, and then a way to connect to it from anywhere in the world. So this should fill the design, engineering and design part of this. And then obviously algorithms and data structures, the second artifact is exactly this. So that should cover all of the enhancements, the code review for the existing code that I have, and describe how I intend to fulfill the requirements of the course outcomes through the enhancement project. Thank you for your time.